In this video I'm gonna treat the puzzle the ceiling lamp, and it's a rather advanced puzzle, and I'm happy to have received a very elegant proof by ricardpe, a very loyal follower on X, and I will go and follow his approach. What we see here is a regular octagon with 8 vertices and all equal sides, together with 2 diagonals and a square which has one vertex halfway the upper side of the octagon and one vertex in the intersection point of the 2 diagonals. And the question is to prove that the 4 red points are concyclic, so they are lying on one circle. Well, let's start our journey. First, as always, I will make visible all the points like this. The first thing to do is to add in some length. Let's make the length of one side 2 for convenience, so that makes this 1 and this also 1. That makes this side 2. And what we easily see is that this side is the square root of 2, so square root 2, like here. And of course, because from the octagon this is a right isosceles triangle, so it's easy to see that here I have 45, here we have 45. Those are features of the octagon. So this is basically half a square, so we have a square root of 2 over there, and again we have a 2 over here. And the first things to notice is that 1 divided by square root of 2 is exactly equal to square root of 2 divided by 2. So that means that the angles, like this angle, if I over here, so if I put the segment, so that angle must be equal to this angle, because they are both right triangles, and the tangent of that angle is 1 over square root of 2. And indeed you can see that. Let's make it a little less confusing with the numbers, so over there, but we know that they are the same, like this. So that implies, because you can, if you look at this, these 2 segments, you know that they are in line, because if you add up the angles, so it's this angle plus this angle obviously is 90 degrees, and we have also a 90 degrees, so those 3 angles add up to 180, which means that this point and this are in line. So they are collinear. So that basically, because we have a right angle, we basically know that here we have another right angle. So that's our first result. And why is that handy? Because if we draw the segment from there, we know that because this angle is 45 degrees, we know that the angle over here is 135. So that's one argument. But now we're gonna look at the angle over here, and what's again striking, if you compute the length of this diagonal, first of all, you can see that the side of the square has length square root of 3. That's easy to show with Pythagoras. So in this right triangle we have Pythagoras, so this area is the square root of 1 plus 2, which is 3. So that makes the length of the diagonal square root of 2 times that, so that makes the length of the diagonal square root of 6. Like that. But now we look at this segment over there, and using again Pythagoras, so the square root of 2 plus 4, lo and behold, it is also square root of 6. Like this. So basically what we know is that these two sides have equal length. So we have established here a isoscalous triangle, and we have already found that the top angle is 135. That means that both those two angles are half of 45. So let's say it's 22.5, and indeed it is 22.5. So that angle is 22.5. Now we're gonna compute the angle between here, here, and here. So what's this angle? And well, that's easier to do because it's an angle basically in the octagon, and let's draw the circumcircle of the octagon like this. So this angle from the Thales theorem is equal to that angle. So equal to this angle is equal to that angle, and well, in the octagon we know that this angle is 135, so 90 plus 45. There is also an isoscalous triangle, so it is similar to this triangle. So we know that this angle is 22.5, and if we apply a Thales, we know that this angle is also 22.5. We know the angle from D, but that's also the angle from this point. So now we are basically done, because from this chord the angle to this point equals the angle to that point, and then we know that those 4 points are on a circle, on one circle, so they're concyclic, and indeed we can draw it, and you see they are indeed on one circle. And that completes the proof of the ceiling lamp.